Welcome! In this video, we are going to explore powers of 10 in scientific notation. We will see how we can use them to express extremely large or extremely small numbers that often appear in science. We will journey from the tiny world of atoms to the vast expanse of galaxies, all using the magic of powers of 10. As a preview, consider that atoms are about 10 to the power of -10 meters in size, the Earth has a radius of about 10 to the power of 7 meters, and galaxies can measure up to 10 to the power of 23 meters. Get ready to learn how to handle these numbers with ease. So, what exactly is scientific notation? Scientific notation is a way to express very large or very small numbers using powers of 10. It provides a standardized format that makes it easier to work with these numbers. The standard form of scientific notation is a times 10 to the power of n, where a is the coefficient, and it is a number between 1 and 10, including 1 but excluding 10. And n is an integer exponent, which can be positive or negative, depending on whether the number is very large or very small. Let's first explore powers of 10 with positive exponents. These are used to represent large numbers. By recognizing the pattern, we can easily understand how these exponents work. 10 to the power of 1 is simply 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1000. 10 to the power of 4 is 10,000. And 10 to the power of 6 is 1 million. Notice how the exponent tells you the number of zeros after the 1. Now let's look at some examples of large numbers expressed in scientific notation. The Earth's radius is approximately 6.4 times 10 to the power of 6 meters. The speed of light is 3 times 10 to the power of 8 meters per second. The distance from Earth to the Sun is about 1.5 times 10 to the power of 11 meters. And Avogadro's number, which is used in chemistry, is approximately 6.02 times 10 to the power of 23. Now let's turn our attention to powers of 10 with negative exponents. These are used to represent very small numbers. Again, by recognizing the pattern, we can easily understand how these exponents work. 10 to the power of -1 is 0.1. 10 to the power of -2 is 0.01. 10 to the power of -3 is 0.001. 10 to the power of -6 is 0.000001. And 10 to the power of -9 is 0.00000001. Notice how the negative exponent tells you how many places you need to move the decimal point to the left. Here are a few examples of small numbers expressed in scientific notation. The diameter of an atom is about 1 times 10 to the power of -10 meters. The mass of an electron is approximately 9.1 times 10 to the power of -31 kilograms. The width of a DNA molecule is about 2.5 times 10 to the power of -9 meters. And the size of a virus is about 1 times 10 to the power of -7 meters. Now let's learn how to convert numbers into scientific notation. Here are the steps to follow. First, move the decimal point until there is only one non-zero digit to the left of the decimal point. Second, count how many places you moved the decimal point. Third, write the number as a times 10 to the power of n, where is the new number you obtained after moving the decimal point, and n is the number of places you counted. Fourth, if you move the decimal point to the right, then n is positive. And if you move the decimal point to the left, then n is negative. Let's look at a few examples. The number 5,600,000 can be written as 5.6 times 10 to the power of 6. We move the decimal point 6 places to the left. The number 0.0043 can be written as 4.3 times 10 to the power of -3. We move the decimal point 3 places to the right. The number 120,000 can be written as 1.2 times 10 to the power of 5. We move the decimal point 5 places to the left. Scientific notation is extremely helpful when dealing with the wide range of scales in the universe. Let's explore some examples from the microscopic to the macroscopic world. In the microscopic world, we have the following examples. A proton has a size of approximately 10 to the power of negative 15 meters. An atom has a size of approximately 10 to the power of negative 10 meters. A virus has a size of approximately 10 to the power of negative 7 meters. And a bacteria has a size of approximately 10 to the power of negative 6 meters. In the macroscopic world, we have the following examples. Mountains can reach heights of approximately 10 to the power of 4 meters. The Earth has a size of approximately 10 to the power of 7 meters. The Sun has a size of approximately 10 to the power of 9 meters. And the galaxy has a size of approximately 10 to the power of 21 meters. Now, let's explore how to perform mathematical operations with numbers in scientific notation. Here are the rules for multiplication and division. For multiplication, multiply the coefficients and add the exponents. For division, divide the coefficients and subtract the exponents. Here are some examples. 2 times 10 to the power of 3 multiplied by 3 times 10 to the power of 4 is equal to 6 times 10 to the power of 7. 8 times 10 to the power of 6 divided by 2 times 10 to the power of 2 is equal to 4 times 10 to the power of 4. 1.5 times 10 to the power of negative 3 multiplied by 4 times 10 to the power of 5 is equal to 6 times 10 to the power of 2. So, why does scientific notation matter? Scientific notation provides several benefits. It simplifies calculations, making it easier to work with very large and very small numbers. It allows easy comparison of scales, helping us understand the relative sizes of different objects. It reduces calculation errors by providing a standardized format. And it serves as a universal scientific language, allowing scientists from different fields to communicate effectively. Scientific notation finds applications in various fields. In physics and chemistry, it is used to represent atomic and molecular sizes and quantities. In astronomy, it is used to express distances to stars and galaxies. In computer science, it is used to represent memory sizes and processing speeds. And in biology and medicine, it is used to express the sizes of cells and microorganisms. In summary, scientific notation makes the universe's extremes manageable through mathematics. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.